once again, the simplifier here with you, out to simplify the learning of science. And today, chemistry again. Remember, what in this world is not chemistry? Everything, virtually everything around us is chemistry. Your hair is chemistry, it's made up of sulfur, the element. Your body has a trace of carbon in it. Your teeth has calcium. Every part of you, even your neurons, remember, we have potassium ions and sodium ions going interchangeably around your axon. Everything about life is what? Is chemistry. Your shirt, cotton, is chemistry. Timber, everything around you is chemistry. So there is no one thing on earth that is not linked to chemistry. Now that is how important chemistry is. But remember, chemistry involves matter. Chemistry involves compounds. Chemistry involves mixtures. Remember the difference between a compound and a mixture? One major difference is that a compound can be represented using a chemical formula. A mixture, on the other hand, cannot be represented using a chemical formula. And that is why blood is a mixture, because there is no formula for blood. But soap is a compound. Remember, soap is a compound because soap has a formula. And what's the formula for soap? I hope you'll not run away from me. C17H35 COONA, sodium octadecanoate. So it has a formula, meaning that soap is what? A compound and not a mixture. So I've given you one major difference between them. A compound can be represented using a chemical formula, while a mixture, they are just physical constituents. They do not have any chemical formula to represent them. So remember that. Remember that. That's a little secret. Hold it on. Look at this. They say, what is the formula of the compound that is formed between magnesium ions and carbonate ions? You know, one major problem that students have is how to play around this to create a formula that can be used to illustrate a major compound. Sometimes you say magnesium triazocarbonate 4, and students who admire you keep looking at you this way. What is he saying? Sodium chloride, what is he saying? I just mentioned sodium octadecanoate. What is he saying? All of these things. Now take note, most of these compounds form are a combination of elements. Look at this. I have the element oxygen, I have carbon, I have magnesium. But now they want us to class it in two. The magnesium ion and the carbonate ion. They want these two to come together. Remember, this is a cation and this is an anion. So what they are asking us from this is, if I combine magnesium ion and the triazocarbonate 4 ion, what will be the formula of that compound that is formed? There is no big deal to it. I give you a secret. Tell no one. Tell no one. Keep it to yourself. If you want to combine ions, all you need to do is look at their valencies. What is this? 2 plus. Look at this. There's a 2 minus. So if these two are to combine, the 2 will cancel out. Now they are only cancelling out because the numbers are the same. So 2 and 2 will cancel out. So the formula formed between this and this is just going to be what? MgCO3. Seriously? Now look at this. What if we have something like this, okay? I have sodium ion, I have chloride ion. Remember, this is 1 and this is 1. Same number, they cancel out. So the formula formed between, the compound formed between sodium and chlorine ion here is what? Sodium chloride, NaCl. Is that clear enough? Look at this. I give you yet another example. If I have this, calcium 2 plus, and I have Na3 minus, my calcium ion and my triazonitrate 5 ion, what will be the formula of the compound that will be formed between them? Look at this now. The numbers are different. I have a 2 here. I have a 1 here. So what we'll do here is what? Exchange of radicals. Because the numbers are not the same, these 2 will jump over to nitrates. This 1 will jump over what? To calcium. So what do I have here? CaNO3. Remember, there is a 2. Now, but because you cannot expose these 2 numbers, you use a formula, a bracket rather, to what? To encapsulate this. So this is my calcium triazonitrate 5. I hope you got that. So what secret am I leaving with you today? Once the valencies are the same, they will cancel out. Just bring the numbers, the ions together. Now, but if it is different, there will be what we call exchange of radicals. And that is that. So what I want you to do is go and start combining ions. Go and start combining radicals. There is no one compound that at this point you should not be able to solve. Just apply this mechanism. Remember, what in this world is not chemistry? Are you holding on to me? Let's move together. See ya.